Recording is on.
So I just downloaded from Vector website and I have installed it. So just I'm opening now. So I think it's already opened here. So then I will give OK, and then yeah, I will open this some configuration can system demo. So how to create the configuration? We go new file and then new. So here we should select like how many channels we have, and then whether it's a can or can fd. So I will take this two channel one. You need to double click on this, and then you can give the name demo project. So this start button, if you have a license, so then it will enable, but in our case we don't have a license, so it is disabled now. Okay, so at least we will go through all the windows whatever we have it currently. So in the same way, here you can see file, new configuration, and here you need to select the channel, like how many channels, whether you're using can, standard can or can fd. So that I did, and then so we need to set a baud rate actually. For the baud rate, so we have two types you can set. So one, you can go here, we have this hardware, and then network hardware. So here, as I mentioned, the standard can baud rate we can set is 500 kilobits per second, and for the extended one or can fd, so I will you we should select here iso can fd, and then we should set this here. Actually this is the 500, and this one should be 75, and this one should be 2000, and this one also 75. So if you don't give the correct baud rate, you will see the error frames in CANtrace. So one I have it in the current project which we are using. So this is if you have the hardware, so it will show the type of hardware. So Win131630, and controller, the vector can or can fd, and then the can piggy high speed scan and exists. Yes, so here you can see can and 500k baud rate. For the can fd, you have to set like this. So iso can fd baud rate, and then 500k, and data rate is 2000. If you come down a little bit, you can see this baud rate and sample point and prescale. So if anyone in the call in the line now, so if you know in deep, you can also tell no restrictions, Kumar sir or anyone else. So more about the baud rate.
Yeah, the more problem you might experience when you're working on the online activities of Canalizer. So probably these channels might, when you restart again the next day, I mean the settings might change actually. So there is some kind of a default settings like what Anand has highlighted here, like ISO settings. That should be the standard one, and we can just run this routine often and connect with your online devices actually.
Okay.
And hello, yeah.
Yeah.
To add the point, basically we'll get the sample point from the CAN DBs. Like for example, it's if you are adding any CAN DB to the configuration, in that we can get the sample point. For example, for few DBs, like which were using like for I-range DBs data transmissions, we use some type of sample points, and for some other DBs, we'll use other sample points.
Okay.
And for the clear transmissions, we'll also tick on the TX self acknowledgement. That also will tick enable it in CANFT.
Okay. So
Yeah.
it will be give acknowledgement TX.
Yes, yes. Like because while doing UDS or anything, like we want any get transmissions from that another issues. Like in CANoe configuration, what we'll do, we'll enable only one node and we'll disable everything.
Okay.
Sometimes,
Hmm.
like to get that data, also we have to enable that. Yeah.
So, do you know why we select this settings
Yes, yes.
like
Basically,
sample point, and then we have this
baud
B
rate
L?
and the prescale value. So basically, why we'll select is like in CAN-DBs in communication. Will, for example, if you are using one particular type of ECU or a particular node, in that node we'll have one type of sample rate and precycle mentioned in that DB.
Aha. Okay.
So,
So,
because while in canal communication, we are simulating our signals, transmissions, and everything. So, we request signals and we send the signals. So, for that, we need some values. So, that values we'll get from the DB, and that's why we'll select it here.
so you mean this settings we get it from the database?
Yes, yes,
Okay, it is not standard settings.
yes,
Okay.
yes, yes. Because like I worked in my company, in that we'll use 175 for some car, like for few things we'll use 80.
80, yeah, yeah, yeah. That's true because in
Yes.
previous organization they were using 80. Yeah.
Yes, because depends upon the DBs we are using.
Mm-hmm.
Yeah,
Okay, thank you.
yeah,
Yeah. So this is one important thing we need to configure. Otherwise, we may get some errors in the uh, baud rate. So, and other one I just noted like panel design. So this panel, the second aspect is to design the panel. The panel is designed to control the each messages. Like we have the radio and slider and switch. The panel provides the way to manually control the signals. They're controlling the messages. So we can just try to open the panel. So here we have we need to go home and we have panel and then new panel. If we have already have a panel also we can add also. So now new panel. So it looks like this. empty panel. So as you see here, there is a toolbox. So you can add a button. Just I'm drag and dropping, and then progress bar, and you can take the switch as well. Yeah. So like you can design the panel, and then you can assign I think you might aware of we have a signal and messages. So signals we can assign here in the properties. So we can change the name as well. Like now the control name is a button, so we can put some signal name, ad underscore signal. So the name we can change as it's customized. And so we need to add symbol value means we can select our signals here. I think since we don't have any database, we can't see much messages here. So here we have a system variable like this one, so we can add. So give OK. So this control does not support the type of the selected symbol. Please choose another symbol valid during the measurement. Okay. So, but we can select, we can assign the variable or signal here. And okay, text. We can give ad underscore signal. Yeah, it changed name, and this switch as well. So we can give the value for this, like so when we press this, and what is the value, and when we release, what is the value. So what we can assign the signal to this. I think here we can assign this values, and then when we press, so like turn off, turn on, so those control we can do in this panel. So and we will go here. So this is what now we just checked it, and adding controls to the panel. So anyone else wants to add some more information to the panel, you are welcome to add. So as I mentioned here, setting properties, we can change these values. So the same thing here you can see in this picture as well. So we can add the environmental variables here. So you can save this panel design, and whenever you want, you can open it. So this is the we can open view and panel. And Kumar sir, anything you wanted to add? Something, you guys?
When you can add some event, right? Event on clicking, just pass some messages. Okay, once you click that button, you will have a pop-up message.
Yes. So you can add that one in the capel scripting, right? So that like whenever you are running, so please press OK to continue something. You will see that message. You're talking about that one.
Yeah, yeah.
So but this one is like we will be controlling like manually if you wanted to uh, in our case or in which I have experience is like you need to go to the graphic window and then set
Mhm.
some signal values. Okay.
Yeah, the best example I would like to have something like when you press the brake button, the backside of the vehicle, the light will goes glow, right? So we can have kind of a button. As soon as you press the button, the light will be the some kind of radio button. The light will be turned into red actually by default. I mean, it will be otherwise it will be kind of an something like different colors actually. So those kind of an application through panel we can design it, right?
Yeah, yeah. And in our case example like the seat belt status always the default state is in it, which means it will take it as a faulty. So what we made it those system variable we took it and we did it the panel design. So whenever we start the cano, just we will press the button. Then it will be like buckled state or unbuckled state. So in that case, we won't see any DTCs. So that is what we use this panel design. So anything else you guys needs to add here, because this is not like I only speak, so you can also add some inputs or yeah something you from your experience. So that is what this purpose of seminar.
And also, we can add the automation part, right? I mean, when you are trying to automate some of the tools, I mean, you can use this panel design, put the button over there, and try to automate that. Okay, and call those signals through capital scripting, and it will go automatic sequentially, actually.
Mm-hmm.
So, like what we generate a .can file
Mm-hmm.
from the CAPL script, and you try to load it on one particular environment of CANoe, and then you can use this panel design to activate those .can files actually,
Mm-hmm.
and it will be applicable for more on to the automation part. Okay, that's normally they do for validation of test cases. Okay, so with the help of this panel, we can try to automate the test cases.
Mm-hmm. So it will be coming like this panel. Whenever we start the cano, it will come. So then I can press. So then the whatever the value we set, that value we can see in the trace window. Correct, sir?
Yeah, absolutely right. You are right.
Yeah. Okay. So then I'll go next slide. I think this is done. Yeah. So we will just. So we have.
So, from interviewer's perspective, what are the questions they might ask in panel? From the interview perspective, let us say you are trying to join one company and they ask you to design a panel. What they'll ask?
That's a good question. Uh, anyone can answer in the line. I don't know any how many people are there. Yeah.
Yeah, hello.
Yes.
Yeah.
Yes.
So basically, related to panel, most of the questions will be asked is like hmm, how you are controlling, like how to attach a CAN signal to the panel, and also for a panel we can also attach the environmental variables, which will be using for the capital automation also. So related to this type of terms, they will be asking in interview. So basically, like you have to control an can signal by using panel, and you have to get the estimated output. In this type of design, they might be asking the interview mostly.
So that environmental variable, you can create your own environmental variable using existing signals, huh?
Yes, yes.
So
We have to create it. Then for every particular signal, we can create it. That also we can attach in the panel, because some signals will be event triggered, some signals will be like periodically it's going on. So to check that, will add an environmental variable sometimes for few signals. It's not that the main reason, it's one of the reason.
okay.
Yeah.
Yeah. So you got answer, Kumar sir. Yeah.
Yeah, yeah. Go ahead. Thank you.
Ah. So our next slide, we need to talk about this interactive generator block and logging block and replay block. So these are the types of functional blocks. So we'll try to add and check. So now we will try to add this interactive generator. So it is just like this, and then we need to configure this. So I think here we should add frame from database, add can fd frame, and then add can frame. So this is the can frame, and this is the can fd frame, and this is the from database also we can add. I think we don't have any database. So why we use this IG black? I think everyone knows in the automotive, and then but in our project we are not using much this IG block. But this is one feature which where we can use like without stopping our CANoe simulation, we can send some messages periodically or manually. Like if you wanted to send cyclic time 10 millisecond, so you can also use this and then send it. uh, so just we need to press this, that's it. So then it will start sending periodically 10 millisecond. But value also you can select. But if you have actual can message, so that you can see what is there in the data, so you can simulate that values here. So we go how to add functional blocks to the simulation. With the interactive generator block, you can configure and send messages while a measurement is running. So this is what now we did this. So right click and we create this IG block, and we can send, we are sending the particular can message, and that we can see on the trace window. I think that's it from this interactive generator. Anyone has any more experience with this interactive generator block? Want to add your experience?
Yeah. So to add my point for the IG block, basically when we got the new DBs, we'll create configuration for the DBs. So in case of sometimes if we don't want to create any configurations or any nodes simulations using that DBs, we'll use the can IG block. So basically in CANIG, we'll add the message signal. From message, we can send the type of, in that message, we can send the signals. And for some time in automotive, we have to do the timeout of the signals, and we have to check that also. So through IG blocks, we can time out that particular signals, and we can check these properties of that signals also. Yeah.
The best example would be if you are working with a car with a hybrid version, which is having a battery connected,
Mm.
and the battery has to have various kind of cell voltage, and also it has a MAC ID with respect to the cell voltage. Let's take some simple battery which is around 63 kilowatt. which consists of some particular cell voltages, let's say around 20 cell voltage. You need to have a 20 MAC ID, and we need to examine the frames, the what you call the CSC frames of the cell. Okay, it is working properly individually actually. So
Mhm.
we can use this IG block in that scenario and send those messages and make sure that you get the proper voltages. Something like we have some threshold voltage which is going to be maintained actually. So make sure that your cell is pretty generating a good cell voltages. So we can use this kind of an IG block. I mean, there are a lot of applications. You can use it in EVCU, okay, like electric vehicle control unit. I mean, you can use it in EDMs. You can use it in motor. So many ways of examining the correct threshold values, actually. So
Mhm.
this is a one kind of real time experience, actually. Thank
Okay.
you.
So you can you can see you can send the 20 messages at a time in the using these IG blocks.
Yeah, you can see it. It is an individual one. It's an individual. So you're talking about the cell one. You try to log that cell one and send that messages. Okay, it will take some time to send the can through IG block. It'll show you the cell voltage, what signal it is taking, how the signal is coming, what values are getting. There are so many parameters for one particular cells. Those variable which been interacted with the CAN-DBC file, and the CAN-DBC file you are checking that whether values are popping properly or not.
Mhm.
Okay. So in this way, you are basically updating the firmware of the battery. You know, the battery has a firmware. You are checking and examining through IG block whether the firm is properly updating or not. Actually.
Okay. How to add a functional blocks to the simulation? Interactive block by selecting the configure. Another window will open, and then yeah, this is what actually I said now. So if you have the proper can messages, you can see this information. So like you can set as well this value to 1 and percentage it will come, and you can simulate, you can send it that value here. So yeah. And logging, I think this is also one important thing in this kind of configuration. So logging, just if you select here and press this space, it will enable. But here we should configure this logging file, like where to store. And yeah, so here for example I'll save here in this, select the folder, okay, and give the file name, some file name, uh, test test case one something. And then I think we have this binary file format and the ASCII file format in this one. So we use BLF file, and in previous organization they used to use this ASCII file. I don't know why that, but yeah, that depends on the project to project or company to company, I think so. That is.
You can use ASCII, you can use BLF. The BLF, it will suppress more data
Mm.
and you will not having much usage of your system hardware usages. If
Okay.
you use ASCII, it will have a more data and probably you may end up with fully occupied hard space actually. So there will be no space at all. So normally they go with BLF file because then you can also convert from BLF to ASCII, which is there in that tools menu. I mean, they can do a lot of things on that actually. So
Mm.
BLS is the one where you can have more data actually when you go for offline simulation actually.
Okay. So anything else you guys need to add here? Because I only used, like I used to select this destination path and then start logging. So there are a lot of thing here. Something you can field codes, username, measurement, index, start. Something is there. I haven't explored these things. If you guys have experience in this, if you would like to add some inputs, or you can add. So Kumar sir, I think you are using this more, right, in the Veoneer.
Yeah, see, these are the log files. Whenever there is some kind of an vehicle is not performing well, I will try to take the log file. Okay, so either it will be an ASCII file or the binary file. Main thing is the what the log file will tell you. It will tell you what are the signal names, how it is performing well, okay, what signal it is running and what channel it is running basically, and what are the lines, the bus lines, the major bus lines will be there. Dedicated bus lines is from the EVCO perspective, and dedicated bus line from the battery perspective, and dedicated bus line from the various kind of a component like IPC clusters
Uh-huh.
and all other things actually. So basically, I try to take those log and try to put it into the different. There are so many other tools like Inca table. Inca is the one tool which try to create those system variable which is compatible to any CAN DBC file and examine those readings, how it is working, and checking those values are within the permission limit. And more importantly, this CANoe tool has a wonderful trace window. I mean, if you go to the trace window, you can see that a lot of message keeps on popping up when you connect with the CANoe device
Hmm.
online, and we see the messages keeps on popping up, and that message you can actually check and examine the graphic tool. There is options called the graphics
Yeah, yeah.
in the and the analysis part of it, and you can examine the curve, how the it goes to the dominant bit or the successive bit, how far it is the curve is going, and how the curve is behaving, and what triggered that curve to go down. All these things we can examine with the help of this log environment. Okay, so this is the one normally we try to take those logs actually.
Yeah. So I mean, Kumar sir, like here you have like it was empty previously. So if you go field and you can add this username, and then you can add computer name. So this one I haven't explored. So the just I ask you if you explore this. You just
This is for network, basically on the network side. Actually, I mean, we are not using because we are directly interacting with the common. Suppose you're used from one geographic lesson to another through IP address, then we can use those computer name, logging system, and all the stuff. Actually,
and then you can also increment by files like the logs like 10 MB or 20 MB. If you have size limit, you can also use this increment by size. You can give here 100 MB, something like that. So now only I explore this, so I haven't used this.
yeah.
So yeah, and then yeah, so that is the logging. So next one is functional blocks. Yeah, so here logging you can set this configuration, and this one is yeah. So replay block. So as you can see, we can add this replay block. For example, if you are working in the vehicle and you get some log, so you wanted to um, replay and see what data it has. So this is the way we will be adding the nodes and we will be adding the log. For example, now replay block. Yeah, so here is this, and then here we will just configure. If you have already log, so we should select here the log, and then once you select, you should map as well, like in the vehicle or in the vehicle. I think if you're working for the specific node, you should know what can channel your node is connecting. So the source and the target you should give here. For example, in the vehicle, it is can channel 2, and here also you should give 2, and then you should give OK, and after that configuration, yeah, can option. So then Again, you should start here. Then it will replay the log which you get it from the vehicle. So then you can see on the trace window that log. So now nothing is there because we don't have log. Um, any more information regarding the replay block? You hello, hello. Okay, so then I will go next one. So this is just a configuration of replay block, and then I think this is the node. So adding the node, just we need to right click on this here and then add. So here two things are there. One is insert capel test module, and then we have this insert network node, and then we have .NET test module, XML test module. So what is the difference? You guys knows this, the capel test node and the network node.
So network node is like the, for example, in car, for example, in real time scenario, we'll have multiple like 18 issues. Okay.
Mm.
For each issue, there will be like type of particular signals, transmission and receiving signals. So in CANoe configuration, we can keep that node, like that one particular issue as one node, network node, which we can send in this bus network. We can send TX or RX messages or receive it through this bus channel, that is the network node. So basically we can create manually that network node, or otherwise we can create through the CANoe configuration, like through in simulation we have a model wizard. In that model wizard, when we insert the network, insert the no dbs, then you can also get automatically, this all nodes will be created automatically, or otherwise you can create manually. So coming to the capel test node, like basically, for example, if you take logging, you can make a capel script to make the logging file automatically and to open the logging file automatically. For that we can use the capel test node. There we can write our capel script. And coming to XML file, in XML file is nothing but for the diagnostics UDS, we'll make some values. So for that, we can create XML test module. But I did not work on much on that, but I worked on this network node and the capital test node. That, yeah.
Okay, so this network node, like you can create, for example, what I used is, so we don't have the BCM node,
Hmm.
BCM real ECU. So we used using this insert network node, and we will create
Yes.
that BCM node. Uh,
Yes. Yes.
so we can simulate. We have input from the break module, so that we will be creating this network node and simulating their signal. There we use their database, and then we simulate the input to our node.
Yes, yes. For particular every issue node, like for example, BCU, we'll have a .can file for that. For
Hmm.
example, if you're using those, we'll have a PDC.can file. For BCM, like some modules, lights.can file, like that type of files. That we'll insert in this network node.
And as you mentioned this capel test module, so we will use the for example, as you mentioned, that logging one, and
Yes, yes,
another one, like if you wanted to do this automation things, like if you wanted to send particular messages or particular signal to be monitor, or you wanted to send some time delay as per the project requirement, so we can use this capel node and we can uh,
yes,
send that signals or message, right?
yes, yes,
Okay. Yeah, I think this is also one more important thing. So measurement window, static window, trace window, data window, graphic window, and write window. So measurement window, as you can see, this is the measurement window analysis. I think this one is measurement window. You can see here. So if you have the log, you can add also here also, right? You can just put it offline and load the log as well in this measurement window. That is one I worked. And then we have trace. In trace, you can see all the can messages like tx and rx messages. And as Kumar mentioned, the graphics, you can see the actual waveform of the particular signal, like it will be in the form of zeros and ones, so that you can see in this graphic. And logging already we discussed. This can statistics, actually we haven't used much, but as I understood, for the can statistics you can see this bus load, what are the messages consuming how much, so that we can see in this. So I think the same thing is in this ppt, we just go through. Yeah, so this is the measurement window, as we already see. You guys want to add any thing, any more information to this slide? Okay, so statistics window, as I already mentioned, serves as a numeric display of frequencies of data, remote error, and overload frames, bus loading, and also displays the state of the CAN controller. As you can see in this statistic window, bus load, and then you can see the remote error and overload frames. So that is the purpose of the statistic window, but we haven't used much. But this is very useful window where some projects they may check this error frame or bus load. Yeah. And now we have the trace window we already discussed. So the purpose of the trace window is to record the bus activities during the measurement. All the messages received as input, a trace block, are displayed lines of text in the trace window. So now you can see we have the tx messages and rx messages here, and this is what you can see the information. So this information come from the database. For example, you have this message. So these messages has this signal. So the signal value they have defined already, and so those values we can see in the trace. So that is the purpose of trace window in CANoe. And the other one is data window. The data window is used to display the signal values. The signal value is displayed as a physical value, as a raw value, and you can see you can see the in data window the particular specific signal values you can see, and the graphical window. The graphical window, as you can see, there is one signal name called water in fuel, and you can see lamp on and lamp off on. You can see the value of the lamp, so that you can see in the graphical window, the right window. So whatever the right window is displays the error messages, the information on the progress of the measurement are output here. Right instruction from the capel or system related warning messages appears in this window. Yeah, so this is what the windows. If you guys have more information, please free to tell.
So in measurement window, basically what automotive will do use of that window is like to check the bus load, because like if in a particular car, if you are sending all the signals at a time, the node can like in the car it can be withstand the power dragging, that all the measurements will be doing. So in automotive, we'll use that to check the bus overload mainly. First, then the main reason for that is, as you mentioned, for
Mhm.
and that coming to trace window, it's like to check the responses and request and sending in a message, the type of frames it's sending in that message,
Hmm.
to check that also.
Okay.
And right window, as usual, like in the capel script, if you are giving any command to check the pass or fail, it's like generally C programming will get an output in the same in CANoe, it's right window.
Mm.
Yeah.
The other thing is that whenever you want to have a debugging, for instance, suppose you are asked, you were asked to ask debug it. How you debug? You have to go to the log file. So when you go for log file, you need to analyze where are the things the messages is popping and where are the messages not popping it up. So you can call this right function there in between and just to go for debugging actually activities, and with respect to your normal offline cans, I mean can logs. Okay, and mention this right command and you can just examine the values are popping up, and you can pass some variable format and print them in the console actually. Okay, with the help of capital scripting we can just print the values whether it is popping correctly or not. With that value we'll be knowing it whether they're having any DLC issues, any error frame issues. Okay, is any kind of an the message is event is not processing because of the correct frame is not properly processed. All these things you can be seen in the trace window. The trace window is one of the key things for all the any of the can bus. It will give you the complete events happening. All the events are coming more chronicle order with respect to your DBC file, and your database file should be know that what message it is populating and what message is updating, and we can examine those trace values perfectly. Doesn't have any error frame actually. So with this logic behind, we can analyze with the help of a graph window. If you take a look at the graph window, for instance, let us say one EVC is giving wrong messages. Okay, at particular when I press the brake button, the light is not glowing actually at the back red side of my light actually. So what happens when I try to see what the EVC is sending the command with the help of graph window? Okay, and when the EVC is sending the command, whether that brake system is acknowledging my command is the what we have to check. So there is a communication between EVCU and the brake models, actually brake control model. Okay, so that communication you can see with the help of graph. Yeah, it is failing, it's not accepting because there is some error frame the EVC is sending. Then you can go to the EVC code and just do modification on that. So with the help of graph window we'll be knowing exact location where exactly it is failing and how it is passing it actually.
Okay, I think this is the end of the slide. So I think today's we done. So and we plan this every 15 days. I don't know if you guys have time, so you guys can join. So maybe next we will have some other topic. I don't know the topic as of now, but if you guys have time, so for every 15 days, Saturday in the evening, Sweden timings. So we will be discussing. I think last week we have discussed about the CAN protocol. So maybe next week, no, not next week, like after 15 days, we have another, like, this is not like seminar, it's a discussion which we can discuss about the technical topics. Like in the office, like you should give the seminar, something like that. But this is like with just whatever experience you have, whatever I worked or whatever you worked, so we can just discuss. No, I mean, no force to, yeah, tell something like this. And thank you for joining today, for everyone. And we will catch up in the next seminar. And thank you for adding input and like interactive session, Kumar sir and Sri Charan. Thank you so much for joining. And
Thank you, Anand. I think this particular session is more knowledge enrichment. What Anand has highlighted on this presentation, it's a good for all the people who has not known and also who has already worked on it. This is a session which drives everyone just to recollect what we have worked in. Maybe down the line for the couple of years back, we have forgotten the basic things also sometimes.
hmm.
So really appreciate Anand for driving this kind of a session and looking forward for more session on this. Thank you very much.
Yes, sir. Thank you. And have a nice evening. See you. Bye bye.
Yeah, thank you for
Thank
the
you.
session. Yeah, thank
Thank
you.
you.